These are the lecture notes for Chapter 18 on the urinary system. For the learning outcomes, we're going to identify the major organs of the urinary system and the location and structure of the kidneys, and compare the location of the left kidney to the location of the right kidney. You will need to be able to trace the path of blood flow into and away from the kidney, and also the functional units of the kidney are called nephrons. So for each nephron, you'll need to be able to trace the path of blood flow into the nephron, through the nephron, and out of it, and also the pathway of formation of urine in each nephron. So it's two pathways, blood and then urine. And then the major functions of each portion of the nephron and the processes involved in urine formation, the factors that affect filtration rate of the kidneys, functions of the bladder and urinary reflexes, the voiding of urine, which is micturition. And then you're going to need to know a little bit about acid-base balance, the conditions called acidosis and alkalosis. And that's pretty much it. So the major functions of the urinary system are excretion of organic waste, such as urea from body fluids, and elimination of these waste into the external environment, and then the homeostatic regulation of the volume and solute concentration of the blood. So these are the organs of the urinary system. Notice on the right side of the body that the kidney sits a little lower than it does on the left side of the body. On the left side, it sits a little higher up, a little more superior. But each kidney is retroperitoneal, and the function of the kidneys is to produce urine. The adrenal glands sit atop each kidney. The ureters lead away from the kidney and transport urine to the bladder, the urinary bladder, and then the urethra conducts urine to the exterior. And of course, in males, it also transports not only urine but semen. So the two kidneys produce urine. The urinary tract includes the ureters, the bladder, and the urethra. And then elimination of urine, we either call that urination or micturition, or sometimes in the hospital you'll hear it called voiding. As far as functions, homeostatic functions of the urinary system, in addition to removing organic waste, the urinary system regulates blood volume and blood pressure. So the urinary system is very closely related to the cardiovascular. The urinary system regulates the concentration of plasma ions such as sodium, potassium, chloride, and calcium. Urinary system helps stabilize blood pH by secreting hydrogen ions to lower the pH when necessary, when it's too high. And the urinary system conserves valuable nutrients like glucose and amino acids. Again, the kidneys are both retroperitoneal, meaning they're behind the peritoneum, closer to your back than your front side. The right kidney sits slightly lower than the left due to the position of the liver on the right side of the body. And then adrenal glands sit on top of each kidney. The kidneys have like this little indentation here, and that is where the ureters and the renal artery and veins enter and exit the kidneys. And here is the structure of the kidney. If you do the kidney in cross section, you see that well, first of all, it's covered by a fibrous capsule for protection. And then the outer layer here that's kind of light colored is called the renal cortex. And all those striations or stripes are made by the nephrons that begin in the cortex, and some extend deep into the medulla. In the medulla, you find these pyramids, renal pyramids. So the renal cortex is the outer layer. The renal medulla is the inner layer of the kidney. And then you have the renal sinus, which is this hollowed out layer that also contains the branches of the that connect to the renal pyramids. So the branches that connect directly to the pyramids are called the minor calyces. They empty into the major calyces, which empty into the renal pelvis. And then the renal pelvis empties into the ureter. Over to the right in picture C, what you're looking at is the bottom portion of the cortex. And I was looking to see if there's like a box or something over here. Well, I guess this is what you're looking at. You see, this is the nephron, and it is blown up here. So this is what a nephron looks like. It starts with a renal corpuscle, and then it kind of has these little convoluted loopy things called the PCT, or proximal convoluted tubule. Then the nephron loop goes down into the medulla and back up. Then you have the DCT, or distal convoluted tubule, the collecting duct, the papillary duct, and that empties into a minor calyx. There's like millions of nephrons. Oh, it says it right here. There's 1.25 million nephrons in each kidney. So they are the units that produce, each nephron produces a certain amount of urine, and then that is collected. The kidneys receive 20 to 25% of the total cardiac output. So that's a lot for just one organ or two organs, to receive. What we're looking at here is, you can see some of the blood supply. So the blood enters the kidney through the renal artery, and then the segmental arteries. And then from the segmental arteries to the interlobar arteries, and then the arcuate arteries and the cortical radiate arteries. Then the blood is drains back into the arcuate veins, and then the interlobar veins, and cortical radiate veins, arcuate veins, interlobar veins, and then we have the renal vein, and then everything drains into the renal vein. So this is in the notes. Blood flow, the pathway of blood flow through the kidney, you need to know this, starts with the renal artery, segmental arteries, interlobar arteries, arcuate arteries, cortical radiate arteries. And then into the individual nephrons would be the afferent arterioles, glomerular capillaries, the efferent arterioles, peritubular capillaries, cortical radiate veins, arcuate veins, interlobar veins, and renal veins. There are two types of nephrons. There are cortical nephrons that are shorter. They're located almost entirely in the cortex. And then the juxtamedullary nephrons have a long nephron loop that runs down into the medulla. Medullary. Losing my words. The renal medulla, yeah. So the juxtamedullary nephrons start in the cortex, but they're longer and they run into the renal medulla. And their nephron loop that runs down into the medulla is surrounded by the vasa recta, which are capillaries that run parallel to the nephron loop. And the combination of blood flow through the vasa recta and filtrate flow through the nephron loop, and the processes that occur with those two, it helps to concentrate the urine. So here you can see the blood supply to and around the nephron. Here's the afferent arteriole, the glomerular capillaries, and the efferent arteriole, peritubular capillaries, and then here's the vasa. Well, this is a cortical nephron. So if you look at this nephron in picture D, here's the vasa recta. And all right, so the nephron itself is the basic functional unit of the kidney. It consists of two main parts, which is the renal corpuscle and the renal tubule. And the renal corpuscle is here. It consists of the glomerulus, which is the collection of capillaries inside, and the I don't see where it's named here, but the glomerulus is the capillaries, but then the collecting, the cup here is not labeled. But anyway, we'll come back to it. After the renal corpuscle, you have the PCT, proximal convoluted tubule, the nephron loop, the thin descending limb, and the thick ascending limb, the DCT, the collecting duct, and the papillary duct. Here it is. It's called the glomerular or Bowman's capsule. So within the renal corpuscle, this is our glomerular capsule or Bowman's capsule that's shown in purple. And then inside of the Bowman's capsule is the glomerulus, which is this network of capillaries. Okay, so on this page, we're looking at the renal corpuscle, which consists of a cup-shaped glomerular capsule or Bowman's capsule containing the glomerulus, which is a network of capillaries. And what occurs in the renal corpuscle is called filtration. All of the blood is filtered. Almost everything is filtered out of the blood except large particles such as the blood cells, the red blood cells, white blood cells, and platelets, and large proteins are not filtered out. But almost everything else is filtered out and collected in the Bowman's capsule. Then we begin the process of kind of fine-tuning the concentration of the urine and reabsorbing some of the important substances back into the blood, like glucose. So after filtration, the filtrate flows, which is going to be urine, but we call it filtrate, flows into the PCT, then the nephron loop, then the DCT, and then at the end, when it moves into the collecting duct, we call it tubular fluid. And once it enters into the minor calyces, we call it urine. So functions of the nephron: the renal corpuscle produces filtrate by filtration. The tubules, the PCT, it functions mainly in reabsorption, reabsorbs useful molecules like glucose and amino acids and some ions back into the blood. Greater than 90% of the water that was filtered out is reabsorbed back into the blood. And then at the DCT, at the level of the DCT, certain things are secreted from the blood back into the urine. So here is the renal corpuscle, and you can see where the afferent arteriole enters and where the efferent arteriole leaves. You can see the lining of the Bowman's capsule is tightly attached to the capillaries, and where they connect, the endothelial lining of the capillaries and then the lining of the Bowman's capsule, where they connect, is called the filtration membrane. And the cells of the DCT that come up and contact in between the afferent and efferent arterioles. These cells are called the macula densa cells. And then the cells in between the afferent and efferent arterioles are called the juxtaglomerular cells, and they're going to help monitor conditions to adjust the filtration rate.